My pleasure to chair this session called Science's Quest for a Better Future, also called the Nobel Session because we have 4 Nobel Prize winners participating. It's a little complicated because, as you see, the first speaker, who I'll introduce in a moment, is live and will be live with us throughout the entire 2 hours, able to answer questions. But he's sitting in France. The second and the third speakers will be represented by video tape recordings, and they will not be with us to answer questions. And then at the end, our last speaker, Richard Ernst, is actually here alive, a real person. So when we have a discussion, it's going to be interesting to see how that works. And we hope there will be time for discussion at the end. The topic is certainly critical. I've observed that many people who win the Nobel Prize get fascinated about not only their own work, but science's larger role in society. And I think many of them feel they now have a responsibility, and this is certainly true in the case of all our speakers today, to work for the good of the world as a whole using science and thinking more broadly about science than they may have thought before they won the prize. So our first speaker today, and I'll introduce them one by one, is Jean-Marie Lane. He is an organic chemist. He got his PhD at the University of Strasbourg with Guy Orisson, who actually was a close friend of mine. He was the president of the French Academy of Sciences at the same time that I was president of the U.S. National Academy of Sciences, and we spent a lot of time together. He was a wonderful man. Dr. Lane then went to Harvard University for some postdoctoral research and returned then to the University of Strasbourg in the Department of Chemistry. And in 1968, he achieved the synthesis of cage-like molecules. You'll hear about these, but they're so-called supramolecular assemblies where different molecules are held together by intermolecular forces to make complex shapes, many of which have great practical utility as catalysts, as sensors of specific other molecules. And this is, as you'll hear, a brand new field, or not so new anymore, but a very important field now in chemistry. It is closely related to biology because, of course, biological systems are composed of supramolecular assemblies. For this work in 1987, Dr. Lane was awarded the Nobel Prize alongside Donald Cram and Charles Peterson for their work on these types of supramolecular compounds. I think you'll hear today that the properties of these compounds are not only fascinating by themselves, fascinating chemistry, but also of great relevance to the theme of BioVision, which is understanding the world of living things, and including, of course, questions of how living systems first arose. Dr. Lane?
Dr. Albers, I was very glad to hear that you knew very well Guy Orisson. He was my doctoral father, and of course I respect him very much. I have fantastic memories of him. Unfortunately, he died too early. Now, little technical detail. I will show some slides, but because of the connection, when it goes from myself seeing me to seeing the slides, there will be a slight delay of about 5 seconds or something like that, and then we will come back. So please excuse us. It was not possible to do it otherwise. Furthermore, I don't intend to speak too much about chemistry. I was not sure exactly what kind of talk, but since the audience, and looking at the program, the audience is very general, I thought of having some general reflections on science as it was requested and as the title of this session sounds. So rather than going too much into chemistry, I will make more general comments. So I guess now we wait just a few minutes. We will go to the slides. Please bear with me just for a few minutes. Thank you. So, the slides are very quick, in fact, it works very well. This is the modern means of communication, get us closer and closer together. So the title of this session is Science's Quest for a Better Future, because that's a vast program, and all one can provide is some reflections on that. And for doing this, let's really start with science right where it started. That means really at the beginning. At the beginning, there was the Big Bang. And at that time, physics was reigning. There was no chemistry, physics, energy, then the universe cooled down, particles formed. And at some stage, when it was cold enough for atoms to form, chemistry started about here. Then these entities, atoms, which had formed and which were making up the elements of the universe, were able to connect together, to go from divided to more condensed matter, get organized, more and more organized by processes which we are trying to understand and which someday will be understood. And then at some stage biology started, leading to living organisms. But the evolution of the universe didn't stop there. It continued, and at some stage on our planet Earth, an organism appeared which was capable of thinking. This is for us here the highest form of complexity in the evolution of the universe, and obviously this was a path towards more and more complex forms of matter. Now, how matter is becoming complex, how has it become complex, is the most fundamental question we might raise in science. It is indeed asking how and why the evolution of the universe has given rise to an organism capable of asking this very question, of generating the means by which it can try to answer this question, and that is science. So the big question we can ask is really, how does matter become complex? From the elementary particle at the beginning to the thinking organism as we know it on our planet. The thinking organism we know, the human being, represented here by this very well-known sculpture of Auguste Rodin, invented, driven by his curiosity, what we call science, the way to try to understand how this has happened. Science has developed many pillars. Let me just cite three of them. On one hand, physics studies the laws of the universe, the very general laws which run our universe. Biology studies the rules of life, a specific expression of these laws, a specific expression which has given rise to our biological world. Between the two, chemistry builds the bridge. It is the bridge which may lead from the general laws to understanding how the given expression of these laws can end up in generating organisms like the ones we know. Now, science is offering very exciting perspectives for future generations. It promises a more and more complete understanding of the universe, an always greater creative power of chemical sciences over the structure and transformations of the inanimate as well as of the living world, an increasing ability to take account over the control over disease, of aging, and even it will be over the evolution of our species itself, a deeper penetration into the working of the brain, the nature of consciousness, and the origin of thought. Science provides knowledge that technology transforms into means of action. Science and its implementation through technology have transformed and will continue to transform our society in many ways. For instance, through the extraordinary development of electronics and new materials, physical and chemical sciences have made possible the advent of the age of information and communication, like we are experimenting today, abolishing time and distance, bringing people closer together. Progress in basic knowledge and the development of new technologies lead from labor-intensive to intellectually intensive activities. All areas of human life and endeavor, for the individual as well as for the society, are concerned. Novel technologies help shifting to much more environmentally friendly and sustainable activities, making less demands on raw materials and energy. Biological sciences and technologies are providing entirely new perspectives to our understanding of and our action on the living world, for health care, for food production, for environmental control. They will have a strong impact on social and personal relationships, on family structure, on law, and on ethical issues. The resolution of pressing economic and social problems cannot be envisaged without fundamental discoveries to open the way to new technologies. It is thus a twofold challenge, intellectual and technical. To meet it becomes ever more fascinating. One must have the courage to match the dangers, the ambition to meet the challenges, whether they originate from the abyss of our ignorance or from the spectre of our crisis. Such perspectives require science and research. Firstly, research is needed for the acquisition of new knowledge. In a time where questions about justification of continued scientific research are being asked by some, we must take a strong stand. Between continuing our investigations and stopping them, there is only one valid option. We must continue, because it is the fate of mankind to pursue the quest for knowledge, because it is the only way to solve the problems that go unsolved, because we do not have the right to close the road to the future. The generations to come would not forgive us if we decided to do so. Secondly, progress in research is needed for the development of novel technologies. Long-term basic research is essential for the progress of our ability to shape the world around us, to free us from the chains of evolution, and to open our window to the universe and to the future. Putting knowledge into practice has provided and will continue to provide human life and endeavor for the individual as well as for the society. They will provide novel and increasingly powerful technologies, giving us new freedoms, new ways of life, and new means of action. We must seize the chances they offer. A major issue is conservation of resources and raw materials, and energy as well. The pursuit of sustainable development for all regions of the world requires that we seek to achieve maximum conservation of energy, natural resources, and raw materials. This means making use of science and technology for the development of highly efficient processes and of new products, such as, for instance, novel types of engineered plants, so as to increase food production and to minimize energy consumption and waste generation. The technologies of life, resulting from the extraordinary progress made in understanding life processes and the ability to act upon them, appear to tamper with the basic mystery and to lift and interdict with the risk of unleashing uncontrollable forces. The realization and potentialities of genetic engineering have aroused many reservations, in some countries more than in others, but the benefits that they can bring are countless, in agriculture, in food production, for instance, but above all, also in human health. Substances extracted from natural sources may be contaminated by compounds that present risks to health. Biotechnologies may permit to circumvent the problems. Thus, synthetic vaccines may be safer than natural ones. The production of human growth hormones by genetic engineering gives a product devoid of the prion that infects the same substances of natural origin and causes the Creutzfeldt-Jakob disease. Numerous other cases can be found. A particularly important one is that of the production of factor VIII for blood transfusion without risk of infection by HIV. Other examples would be the engineering of bananas containing vaccines, or of vegetables producing contraceptives, which would allow women to control themselves, their fertility. An area that holds enormous promise is that of stem cells. Deprogramming and reprogramming cells may well allow in the future the generation of spare organs with no or minimal risk of rejection. My own field, chemistry, suffers from suspicion and rejection on the part of our societies. Here also there is a big misunderstanding. One opposes chemistry and nature, but a compound is always chemical, be it natural or not, be it generated by a plant or an animal or produced in the laboratory. A natural substance has no reason to be less toxic than a synthetic one, which is in fact usually in a much more pure state. In recent years, Bruce Ames has applied to compounds found in common foods the widely used test that he had developed for determining the carcinogenicity of artificial chemicals. The Bruce. Yeah?
We've lost your slides. Can we get your slides back?
No, the slides, I have no slides for the moment.
Oh, okay. All right, thank you.
Slides they come back at the end.
Okay, thank you. Thank you.
Because I thought because of this sort of complicated going back and forth, I didn't take slides. So, as I said, Bruce Ames has developed a test called the Ames test for determining the carcinogenic character of artificial chemicals. And his conclusion was quite clear. Dietary pesticides are 99.99% natural. Let me at this stage evoke briefly the role of science in science and society of chemistry itself. Indeed, chemistry plays a central role, both by its place in the natural sciences and in knowledge, by its economic importance and omnipresence in our everyday life. Being present everywhere, it tends to be forgotten and to go unnoticed. It does not advertise itself, but without chemistry, those achievements we consider spectacular would not see the light of day. Therapeutic exploits, feats in space, marvels of technology, and so forth. It contributes to meeting humanity's needs in food and medication, in clothing and shelter, in energy and raw materials, in transport and communications. It supplies materials for physics and industry, models and substrates for biology and pharmacology, properties and processes for science and technology. Chemistry has traced its path in the evolution of the universe from matter to life. It is the science of matter and of its transformations, and life is its highest expression. Before biological evolution, spontaneous chemical evolution took place under the pressure of self-organization, leading progressively towards living and thereafter thinking organisms. There must have been a prebiotic, fully chemical evolution until we could reach, or the evolution of the universe could reach, the threshold of life. Chemistry provides structures endowed with properties and develops processes for the synthesis of structures. It plays a primordial role in our understanding of material phenomena, in our capacity to act upon them, to modify them, to control them, and to invent new expressions of them. Thus, chemistry is a science, but it is also an industry, as you well know. Each scientific component of the discipline has its industrial counterpart. It has, for this reason, a very marked impact on economic and social life. It is not surprising that chemistry is called upon to face a number of increasingly important socio-economic imperatives associated with geopolitical phenomena. Some result from new economic conditions in the industry, cost and availability of raw materials and energy, others from the reorientation of the chemical industry, the necessity to produce products with high added value, possessing new properties. Finally, still others from social preoccupations concerning the environment and the quality of life, such as improvement in working conditions, safe use of products, protection of the community, fight against pollution. Each aspect of human activity depends upon a better knowledge of chemistry and on its progress, and it can be improved by it. Now, chemistry is also often associated with risk, like other types of technological inventions. But zero risk does not exist. Risk appears with life. Zero risk is a dead world. The desire to systematically eliminate all risk may also become a threat to progress, to freedom of action, and even to democracy. One should not forget that Pasteur experimented his vaccine against rabies in conditions that would make us shudder today. Similarly, it has become commonplace to say that such a fabulous drug as aspirin, which is working wonders one continues to discover, would probably not pass the regulations in vigor today. Environmental protection, when irrationally implemented and short-sighted, may have very perverse effects. I may cite a particularly tragic illustration taken from a review of the greatest unfounded health scares of recent times, a review published by the American Council on Science and Health. It concerns the pesticide DDT and malaria. The ban on DDT was considered at that time the first major victory for the environmentalist movement in the USA. The effect of the ban in other nations was much less salutary. In Sri Lanka, DDT spraying had reduced malaria cases from 2.8 million in 1948 to 17 in 1963. After spraying was stopped in 1964, malaria cases began to rise again and reached 2.5 million in 1969. The same pattern was repeated in other tropical and usually impoverished regions of the world. For instance, DDT spraying in Africa began in the 50s and greatly reduced the incidence of malaria. The ban on the use of DDT in Africa has led to a disastrous re-emergence of malaria, which now kills 3,000 African children a day. In Zanzibar, the prevalence of malaria among the population dropped from 70% in 1958 to 5% in 1964. By 1984, it was back up between 50 and 60%. The chief malaria expert of the US Agency for International Development said that malaria would have been 98% eradicated had DDT continued to be used. Of course, other drugs have been looked for, are being sought, but usually they're much more expensive. Our duty is to optimize the chances and to minimize the risks. The much talked about precautionary principle is a dead end, and doing nothing can be a much greater risk than doing something. For instance, should we really have invented the wheel? The wheel is at the origin of all car accidents. So, What should we do? I think here the answer is quite simple, but don't forget the car accidents are a result of the invention of the wheels. A precautionary attitude would lead to stopping research and thus deprive future generations of knowledge that may be very useful to them. Our descendants will continue to evolve intellectually, culturally, materially. They may, with hindsight, adopt points of view quite different from ours. To stop the machine would deprive them of the possibility of further development and would prevent them from succeeding where we failed. We have no right to force them into such a situation and to hand down judgments in their place. They may well be wiser than we are. A crucial question concerns, obviously, the developing countries. It is the responsibility of the developed countries to offer solutions for closing the unacceptable north-south imbalance, as it is called, and the resulting strains. The accumulated knowledge and wealth and the very efficient advanced technologies resulting from research in the developed countries provides means for the rapid progress of the less advanced ones. At least it can certainly do it, by helping them to jump over intermediate stages of development, such as those of the industrial age and the heavy industry, directly into a high-tech era based on highly advanced technologies that are more economical and much less demanding in raw materials, in resources and energy. The development realized in some countries may then serve for the good of all. Such a direct entry into an era of soft, of human-friendly and environmentally conscious technologies amounts to what you might call a sort of a shortcut, a development shunt. For instance, to be connected to the world, a country may not have to lay more wires, but go directly to cellular phones, and may thus even be at an advantage over those countries which have developed a classical phone network, jumping from node phones directly into connection with the world. Technology transfer should thus be effected at high level. It implies to introduce, for instance, photovoltaic and nuclear electricity generators, not coal or oil-fueled power stations. High-performance materials, not steel mills. Such high-tech transfers related to energy, materials, and health imply that we set the course that will allow in the future to take advantage of science and technologies. And this requires education, the transfer of knowledge, and collaboration. Indeed, science education in our schools, in colleges and universities, as well as for the general public, must be a major priority, so as to train the researchers and discoverers of tomorrow, to lift irrational fears and rejections, to develop the scientific spirit, the attitude in order to find the obscure, the deceitful, the irrational. Beyond the general progress of knowledge and the technological development, the most important impact science can and must have on society is the spirit that it implies, the scientific, rational approaches towards the world, towards life, towards society. Education, science, and technology may indeed collide with traditions and herd beliefs or social structure. We must be prepared for that and take it into account so as to overcome it. For instance, the installation of a solar-powered water pump accessible to everybody in a village of a developing country may destroy, as it has happened, a traditional structure where power was in the hands of those who controlled the water supply. Not to speak about methods of fertility control, to which some circles where fundamentalists from all sides are hand in hand and manifest strong opposition. Thus, science offers new freedoms, but mankind has to learn to live with them. Helping to bring science to everybody is much the responsibility of the media, which at present play at best a minimal role, often a deplorable one. Major improvements must be brought about, and the broad public would certainly be much more interested in high-quality science programs than many media bodies like to believe. There is here an extraordinary contribution to be made at the interface of science and the society. And of course, instruments like the Bibliotheca Alexandrina is a very important tool for this going into that direction. A major factor is the emergence and development of information and communication networks and the resulting modification in the dissemination and transmission of knowledge. Humanity has transferred knowledge and culture through education. The worldwide accessibility of information will lead to profound changes. The whole educational system will have to be adapted, in addition to is also already being on the way, of course. In addition to basic training from nursery school to university, more and more importance will have to be given to continuing education, lifelong, regular updating, so as to provide the flexibility required for coping with rapid changes. The role of the teacher will change profoundly. A major issue concerns the situation of the scientists with respect to ethics and society. It is my personal strong opinion that the scientist has first of all general responsibility to truth, and only then is there responsibility to the society and the world at a particular time in history. Pursuit of knowledge and truth supersedes present considerations on what nature, life, or the world are or should be, for our own vision can only be a narrow one. Ethical evaluation and rules of justice have changed and will change over time and have to adapt. Some think that it is being arrogant to try to modify nature. Arrogance is to claim that we are perfect as we are, with all the caution that must be exercised, and despite the risks that will be encountered, carefully pondering each step, mankind must and will continue along its path, for we have no right to switch off the lights of the future. These perspectives for the future of science, for our future, have already been expressed in most fitting terms by this artist-scientist, the quintessence of artist-scientist Leonardo da Vinci, when he wrote, for those who speak Italian, please read the top. If not, the translation is at the bottom. Where nature finishes to produce its own species, man begins, using natural things, let's say the elements in the universe, the periodic table of Mendeleev. With the help of this nature, this means the laws of nature, the laws of physics, to create an infinity of species. That's a very powerful ending. To create, that's in the hand of science. An infinity of species, all these entities which don't exist yet, which can exist, and which wait to be created. So the future is ours, it is in our hands. Prometheus has conquered the fire from the gods. We cannot give it back. We have it, you cannot give it back. And our path leads us from the tree of knowledge to the control of our destiny, as here you can see Prometheus now brandishing the fire he has taken away and given to mankind. So our path is from the tree of knowledge to the control of our destiny. Let me finish by citing a mathematician. This mathematician is David Hilbert. He's a great mathematician. He's buried in Göttingen, in Germany. And on his tombstone is written a sentence which he wanted to have there. Here it is. Now let me show you that sentence in a more readable form. What is written there? Wir müssen wissen. We must know. Wir werden wissen. We will know. And science will allow us to do that. All of us are here to continue inquiry, continue accumulating knowledge, and finally knowing what we're doing all around. I would like to thank Ismail Serageldin for organizing this conference. This is a major contribution also to education, a major contribution to generalizing, to bringing about knowledge, contacts between people, and thus making a great contribution to our common goal. Thank you very much for your attention.
Thank you, Dr. Lane. I understand you'll stay around for the other talks and be with us at the end when we have a discussion
Yes, I will be around.
Of all these issues. So we will go on through all our speakers and then have the questions and discussion at the end. Our next presenter is Peter Doherty, who's an Australian, and he's appearing for a very brief 2 minutes, I understand, on videotape. So this is more a welcome than a talk. Peter Doherty won the Nobel Prize in Physiology or Medicine in 1966 with his Swiss colleague Rolf Zinkernagel for the discovery of how the immune system works to counteract viruses. They were the ones who discovered what's so-called MHC, or major histocompatibility complex, which has this wonderful property of presenting foreign peptides on the surface of special cells and protecting us against infections. And that was a true breakthrough in immunology. So we'll have Peter with us for a few minutes.
Matter of personal regret that I can't be at this meeting, the New Life Sciences, linking science to society. I also regret that I can't be with you at the Bibliotheca Alexandrina. This wonderful venue reminds us how, after the ancient library was destroyed, the Islamic world kept the light of understanding and knowledge burning through the European Dark Ages. Now, as then, we face enormous challenges. Among those challenges are the issues to do with global infectious disease and the problem of feeding this ever-expanding population in the face of what, unfortunately, is substantial environmental degradation. The solutions to those issues are multifaceted. They include political and social approaches, and they also include the subject of this meeting, science and technology. That's our mandate, to find solutions based in modern molecular technology that will alleviate the difficulties that face our species and will ensure greater global equity. I wish I could be part of this discussion. I've participated in the past and found the issues and the scope and the breadth of these meetings to be enormously useful. I wish everyone well, and I look forward to reading the conclusions that you reach at some future time.
Next talk now is a real talk, 37 minutes, and very professionally done. I've already watched it, so pay attention. It's by Harold Kroto, chemist. He is listed on the program as Sir Harold Walter Kroto, but everybody calls him Harry Kroto. He's from England and initially was studying using spectroscopy, the chemistry around stars, and he discovered long carbon chain molecules by that means. And he then went to Rice University in Texas in the United States, where he did actual chemistry to figure out what these were, and along the way discovered so-called fullerenes, most famous of which, and you'll see these in his slides, are the so-called carbon-60 buckyballs. He shared the 1996 Nobel Prize for this discovery in chemistry with Robert Curl and for the discovery of these fullerenes. And for at least the last decade, he's been devoting himself to spreading science through various passionate speeches. You'll hear one today, and centering on science education, changing the nature of science education, increasing the prominence and understanding of science in the world. And I'm sure you'll enjoy his presentation coming right now.
It's a pleasure to be talking to you today on some serious issues, the new life sciences and linking science to society. And when I deal with serious issues, I usually like to use this quotation by Don Marcus. If you make people think they're thinking, they love you. But if you really make them think, they hate you. And the issues we're going to address are in that particular category. And I'm not here to make you feel comfortable, because I don't feel comfortable about the issues myself. Science, society, and education. I don't know that I have answers. And as I like quotations, this is one of my favorites. Again, I seek not the answer, but to understand the question. So we're going to deal with these questions. Perhaps we'll get to the answers or some answers. And I liked it so much that I thought I'd better go and find out. And who better than Google to find out who first said that? And then I discovered it was me. I'd said it so often that Google thought that I'd originated that fantastic quotation. But indeed, if I change it slightly to I seek not to know the answers, but to understand the questions, we find it's Kung Fu. So there we have it. What are we dealing with? Well, I think the major issue for me is that really knowledge cannot guarantee good decisions, but common sense suggests that wisdom is an unlikely consequence of ignorance. So, the education issues. The problems of the future are not going to be resolved unless all people, almost everybody on the planet, in general, that includes politicians and lay people, have a better understanding of all aspects of science, not just the uses, but the way science thinks and the way that it comes about, the culture of science, the culture that has reshaped modern life. Don't underestimate how serious this is. The science-society interface, and particularly in education, is a battleground, and it always has been. The value of science to society is important. And if we look at this, anesthetics, we can see just how terrible it was in the 17th and 18th century to have an amputation without an anesthetic. Let's really focus in on it. There can be no more humanitarian contribution to society than the gift of anesthetics from chemistry. There are other great miracles too. Penicillin, for instance. This is really an important sort of contribution. This is a real miracle. No need to pray. Look at this. This is blood poisoning of this little girl in 1942. In 3 weeks, she was cured by penicillin. In fact, the problem of the future is that bacteria are evolving with an immunity to antibiotics. Think about it. We desperately need young people in the future to solve the problems of the future that are on the horizon. Science pros and cons. Well, what are they? Let's think about it, because, you know, most people really don't understand what they are. There are certainly negative aspects of the sciences, and accidents certainly do happen. However, the worst aspects of science and technology is that people, politicians, use the science, the technology, to actually have wars and conflicts and send young people to kill each other. I think that's much worse. But in general, I think most people would say that, by and large, science has been very beneficial for society. Let's think about what it would be like to be without chemistry, for instance. All these would be gone without chemistry. And in fact, scientists work together to solve the big problems, help to look after the environment, okay? improve the world health, understand how things work, and enjoy making things. Okay, that's what scientists do. Okay, but what is it? There's a big misunderstanding, and I want to address that aspect of science, the important aspects as far as I'm concerned. The first thing is a body of knowledge, evidence-based knowledge on the way the universe works. Then there's the application of that knowledge, technology. And then, very importantly, the ways in which that knowledge was gained, the scientific method. However, there is something even more important, because the contributions of science have been so valuable to society, they've revolutionized our life. People have forgotten the cultural aspect of the sciences. In fact, people, in particular politicians, they don't really understand it at all. Before science became useful, it had another name. It was called natural philosophy. And the most important aspect, by far, is that natural philosophy is the only philosophical construct we have devised to determine truth with any degree of reliability. I'm going to say it again, because I think it's so important. Natural philosophy is the only philosophical construct we have devised to determine truth with any degree of reliability. And the ethical purpose of education must involve the teaching of our young people how they can decide what they're being told is actually true. The teaching of a skeptical, evidence-based assessment of all claims, without exception, is an intellectual integrity issue, and all teachers should address it as much as they possibly can. Without evidence, anything goes. Think about it. Well, what about natural philosophy? It's actually very new. If we go back to Pierre Abelard of the 12th century, we find that he wrote a book, Sic et Non. And in there he says, by doubting we come to inquire, and by inquiry we arrive at the truth. In this short and simple but profound sentence lies the complete description of the sciences. Now, of course, doubt and questioning are intrinsic threats to the power of those who depend on dogma for authority, who ask you to believe what they want you to believe. And Abelard got into a lot of hot water for this. Francis Bacon in the 16th century, he actually wrote a book called Novum Organum. And in fact, it's on scientific method. Novum Organum in Latin is new instrument. That's very interesting. In the 16th century, science was a new instrument. And he pointed out that we must proceed through inductive reasoning, observe fact, hypothesis to physical law. If we take Pierre's rule, by doubting we come to inquire, and by inquiry we arrive at the truth, and we invert it, then we come to arguably, and I would argue it, the most important statement of all time. To determine truth, we must doubt and inquire. This has had explosive consequences, and only when natural philosophy has triumphed over dogma-based authority have democracy and science developed. Look around the world and you'll find that to be true. Giordano Bruno was a heroic figure in the whole scientific spectrum. Here he is. He wrote a book and he criticized attempts to prove the dogmas of the church by reason. He pointed out that Christianity is entirely irrational and it is contrary to philosophy and that it disagrees with other religions. He also points out that we accept it through faith and that revelation is not scientific. Okay. He also pointed out, was the first person to point out, that the stars were suns like our own, and they were in an infinite firmament. This is a very interesting concept and went further than Copernicus. And for these proposals, he went before the Inquisition. He was imprisoned and finally burned to death by the church. The great enemy of the truth is very often not the lie, deliberate, contrived, and dishonest, but the myth, persistent, persuasive, and unrealistic. Belief in myths allows the comfort of opinion without the discomfort of thought. And here is the person who said it. Big surprise. Now let's think about the sciences, and let's think about three senses. Common sense. Common sense tells us that the sun goes around the earth, okay? Think about it. You look out in the morning, it's over here, and in the evening, it's over there. Common sense tells us the sun goes round the earth. It's uncommon sense, the uncommon sense of the scientist, that tells us that, in fact, it's the earth turning on its axis that makes it seem as though the sun is going around us. This is very important because uncommon sense and bravery of Copernicus, Galileo, and Giordano Bruno. In fact, think about it, because many people accept claims for which there is no evidence whatsoever. Ask yourself, do you know the evidence for this Earth going around the sun? What else have you accepted without knowing the evidence? This is an important issue because scientists are different from all others. We learn that we must not accept anything without evidence. We must question everything and assess all claims without exception on the basis of evidence. It may take millennia to overcome the power of dogma-based authority. The trouble is that nonsense is common now. Let's take another life sciences issue, okay? This is a museum in Kentucky, okay? And here, a friend of mine, okay? The problem is that nonsense is common now. And here in Kentucky is a museum where young children, school children, are going every day. They go, and many other groups go as well. And they're told, did humans live with dinosaurs? God made Adam and Eve on the same day as land animals. So dinosaurs and people lived at the same time. If so, we obviously rode them with saddles, okay? What did they originally eat? Before Adam sinned, all animals, including dinosaurs, were vegetarian. Well, those are fairly non-vegetarian teeth. What happened to the dinosaurs that didn't go into Noah's Ark? They were drowned in the flood 4,350 years ago and preserved as fossils. And here's Noah's Ark. At this museum, they claim that there was a flood 4,350 years ago. And Noah is a Scot. He's got a Scottish accent. There's a big flood coming, and we've got to build a big boat to save ourselves. And here's a young child wondering about these issues, confused. The world is confused about science at the interface with society. Let's think about genetic engineering. Quite a lot of people think it's new. But in fact, genetic engineering by human beings without any knowledge of DNA has made this animal into a chihuahua. And in fact, we might be able to do it in one step now. Okay, we might be able to go from a wolf to a chihuahua in one step. We might be able to make a human being into a chihuahua. And some people, I should suggest we do that to all. A good definition of nanoscience and nanotechnology is atom by atom, molecule by molecule assembly of a complex and or functional system. Okay, by that token, we are wonderful examples of nanotechnology. It's as old as the hills. It is not new. There's a lot of discussion in a lot of places about fossils, okay? And in fact, Darwin's theory of evolution. But one of the most wonderful discoveries in my lifetime is tectonic plate drift. South America and Africa were once joined together 230 million years ago. And if that is true, the animals that roamed South America and Africa were the same 230 million years ago. And we discover that the fossils of the Triassic age are the same. Fantastic confirmation of the theory of evolution. And here is that particular animal. Our cousins, we discover, this is what it tells us, 99% of our genes the same as this young fellow. In fact, look at the face. What more human attitude can you think of? It's obviously an England football fan after losing to Brazil. 70% of your genes are the same as this guy. And in fact, 50% is the same as a fruit fly and the maggots as well. Okay. I believe this one, 70% are the same as pumpkins, and you only have to look at the average politician to realize that that looks like evidence. Science is international. One of the great aspects, it doesn't matter what country you live in, what color you are, what religion you have, science is always the same. And here we have some of our group from a few years back from all over the world, from Spain to India, from Holland to Syria. That's one of the most important aspects of the sciences. There's a language of science, and this is one of the big problems. And I'm going to show you something by Feynman, who discusses the problem of science, in particular physics.
If you're interested in the ultimate character of the physical world, of the complete world, And at the present time, our only way to understand that is through a mathematical type of reasoning. Then I don't think a person can fully appreciate, or in fact can appreciate much, of these particular aspects of the world, the great depth and character of the universality of the laws, the relationships of things, without an understanding of mathematics. I think it's just, I don't know any other way to do it. We don't know any other way to describe it accurately and well, or to see the interrelationships without it. So I don't think a person who hasn't developed some mathematical sense is capable of fully appreciating this aspect of the world. Don't misunderstand me. There are many, many aspects of the world that mathematics is unnecessary for, such as love, and which are very delightful and wonderful to appreciate and to be awed and mysterious about. And I don't mean to say that the only thing in the world is physics, but you were talking about physics, and if that's what you're talking about, then to not know mathematics is a severe limitation in understanding the world.
Well, that was Feynman making a statement about physics. And I think the point that they're making is to appreciate science, and particularly physics, and even and chemistry as well, and the symbolism of chemistry, at a deeper level, at a cultural level, at an intellectual level. To feel it as a culture, you do have to learn the language. And that is a problem. Where does it go back to? People like Al-Khwarizmi, the development of algebra. Robert Ricord on the development of the equal sign. In fact, just look at this. It's very interesting to realize that, in fact, that the equal sign had to be invented. In this book, The Whetstone of Wit, in this page, what we discover is the first equal sign. Okay, there it is on that equation. And here he explains subtraction by the use of a poem. Basically, the language of the sciences was not developed until the 15th century. Things like a half mv squared. Newton didn't know a half mv squared. This equation fascinated me because JA times JB is not equal to JB times JA. And that led to my understanding of the basis of chemistry. And here we have my way of introducing and explaining chemistry in a very short period of time. Okay. Now we have the Earth orbiting the Sun. We use classical mechanics. Okay. For an electron orbiting a nucleus, we use quantum mechanics. Okay. Now then, the angular momentum quantum number is J. Just think about it as numbers, 0, 1, 2, 3, 4. And if you want to understand the modern world, mobile phones, computers, laser, digital cameras, you really have to know quantum mechanics. For a given J, there are two J plus 1 orientations. When J is 0, 2J plus 1 is 1. When J is 1, 2J plus 1 is 3. And when J is 2, 2J plus 1 is 5. Okay, hence the 1, 3, and 5. Now, what I'm going to do is double this, double that set, move this to there, move that to double this, move that to there, and this to there. And what have we got? Yes, the periodic table. Okay, it explains the whole of chemistry. Okay, also all of life, and all the useful bits of physics. Fantastic, based on the numbers 1, 3, and 5. And that's a deep sort of insight into the sciences. Why do we need mathematics in life sciences? Well, let's look at this. Many nurses have pure mathematical skills. They do not know where to put the decimal point. Okay, they might get 10 times more or 10 times less medication than intended, if you're lucky. Okay. In 1999, between 45,000 and 98,000 Americans died due to medical errors, many of them due to the calculation mistake. It's a serious issue, not just for the scientist. Okay. So education, what can we do about it? It has to start early. Like a language, to speak a language fluently, you have to learn it early on in life. To learn the language of the sciences, to appreciate the sciences, you have to learn it early on in life, like this little boy. And I like to compare my upbringing when I was a kid, because I didn't actually think about being I didn't know what a scientist was. When I was a kid, I really wanted to be Superman, okay? And here's the proof, okay? I had a problem flying, so I had to do other things. And in fact, I played tennis, and I did gymnastics, and I acted in a play, Henry V, at school, okay? And here is a picture from that. And if we blow this up a little bit, we see the guy in front. And he stayed an actor. And I usually tell young people, become a scientist, don't become an actor, because the guy in front is now 5,000 years old. And I'm a lot younger than he is. Yeah, Ian and I were in the same year at school. And in fact, he came out to Florida a couple of years ago and did a workshop and a one-man show. Stay with us. The other thing I did was graphics. I wasn't a one-trick pony. I used to really enjoy doing things like this and drawing and many other things. And I had Meccano and made things with nuts and bolts. I also had a camera, and I want to show you this because this was really changes my life. Had to go through all that to get a photograph. So you have to have pretty good reason to do that. And in fact, I did have one when I was doing that sort of thing. Okay. Today, just that. That's all you need. And you've lost so much. You don't know anything about what's going on in the mobile phone. You don't know anything about the chemistry. I knew everything about the camera at that time. All right. So there you go. Education in science cannot be successful in isolation from other subjects. They all need to be integrated. There's no point focusing just on science. You have to do other things and explore other aspects of one's creative potential. A key aspect of science is to make sure that you can check. This is the scientific method. I have my 4 out of 5 rule. If you make a new observation, develop a hypothesis to explain it. Then carry out some further experiments to test the validity of that hypothesis. 5 would be good. If 4 observations out of 5 fit, you're almost, with the accent on almost, certainly right. If only 1 out of 5 fits, you're almost certainly wrong. In fact, 4 out of 5 fits, there's a 99.9% probability that the experiment that does not fit is actually an error. Okay. So let's think about the issues today. Climate change. You see headlines like this: global warming is a hoax, asterisk, okay? But is it? Well, don't accept what it says in the newspapers. Don't accept what other people say. Look at the evidence. Is there more or less rainfall? Are the average temperatures rising in general? Are glaciers receding or advancing? Is the sea level rising? Are animals moving from their natural habits? Is the amount of CO2 in the atmosphere increasing? Are there more or less hurricanes? Is there more ice or less ice in the Arctic or in the Antarctic? Think of some other possible indications and check them out. Take no one's word for it. Work it out for yourself. In fact, decide for yourself on the basis of evidence. But be careful. There are people out there with a vested interest in misleading you. That's the problem today. The future of biosciences. Well, I'm going to introduce my favorite molecule. It's not C60, it's this fellow, okay? Because it's like this, it's my dog, okay? And let's look at it. It's carbon, hydrogen, okay? Blue head, red nose. If I look at the microwave spectrum, because that's what I used to do, I can show that the dog shakes its head and actually looks at its tail, okay? Like this, right? Not only that, my dog is pretty clever, right? Because it can do a lot of other things as well. It can actually have some internal rotation. These hydrogens can rotate like this. And as it's been a dog and it's been drinking, that's why it's got a red nose, it's getting a bit drunk. And if you're drunk, you know what the problem is as you're trying to go home, is that you desperately look around for a lamppost if you're a dog. And if you find one, you're pretty happy. And of course, you can actually use it. Okay. Now, apart from the fact that little kids like that little bit of display, this molecule is flexible. And I think this is the most important aspect of chemistry, of molecules, in the life sciences that we will have in the future. And here is one of the indicators. This is hemoglobin. It's a very sophisticated molecule. It can change its shape when it has oxygen because when it wants oxygen and needs oxygen, it can grab it and hold on to it. And then where it's needed in the body, it can release it. It's a very sophisticated molecule. And here is another one, okay? And that is ATP synthase. This molecule is an electric motor. And protons add to this wheel, turn this wheel, and as this opens and shuts, okay, it opens and shuts that, and ADP plus phosphate are put together. This is a fantastic molecular motor. Inside your body, there are these molecular motors driven by protons, not electrons. And I think in the future of the life sciences, we have to develop drugs and weapons against the enemy, which are as sophisticated as the enemy, the viruses and these things. Remember how brilliant penicillin was. It's just really a simple molecule compared to the enemy. So that's the future. Young people will be able to develop weapons with a sophistication of the enemy. Imagine what you're really doing at the moment. We're using sort of basically bows and arrows against tanks. That's the way I think about it. And so the future of the life science and medical science is extremely exciting. What we're doing is something that's related to the issues of society and at the front with science, because I think we need to solve the education problem. And I set up the Vega Science Trust some years ago to solve these problems. We've got 300 programs, 70 were shown on the BBC. But we've developed something else because things have really changed recently. And the thing that has changed really is the fact that an encyclopedia is very different today from what it was in the past. Encyclopedias are big tomes. They used to be very expensive. And this is Encyclopedia Britannica. And what we now know is that basically we don't need a pile of books like this if we actually go and take advantage of what I call the GUU wiki world. What is it? Google, YouTube, and Wikipedia have revolutionized our world. What sort of revolution is it? Well, let's look at this image of C60, our molecule. If we look in Encyclopedia Britannica, it looks like that. It's not too imaginative. But if we go to the Google image browser, okay, and put any of those names in, what we get are pages and 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 even rotating buckyballs. It's a real revolution, a triple revolution, a paradigm shift in seeking, finding, and accessing information. YouTube fosters the creation of imaginative movies like we're doing now. It's democratized filmmaking. Wikipedia, fantastic. 500,000 people are contributing to a global cache of educational material. In my field of spectroscopy, it's better than some of the textbooks. It's more accurate and written by people who understand the subject better than some of the people who write these textbooks. And we're creating a global cache of URL links to back up Wikipedia. So what are we doing? Well, I call it GYWW 2.0. It's called GeoSet, all right? And I'm coming to you now by GeoSet. We use a capture station. It's a computer, basically. And we have basically an image, video image, and then we also have an image in the data file, in the PowerPoint file. And soon it will be downloadable. It's the future of broadcasting, okay, as far as I'm concerned. And here are some of the URLs for the site. What are we doing? We're doing kids' workshops. I've done children's workshops all over the world, okay, from Japan to the USA to Santa Barbara, and to not only that, to Mexico, to Malaysia, to Iceland, from Florida, across the whole of Australia via the internet. In the UK, Manchester United footballers helped me as well. And here, I like this because one of the children in our workshop actually found a use for C60 molecule. This is my favorite picture. This picture epitomizes what science can do, bringing people together, races together from wherever they are. That's what science can do on an education front. So what are we doing? Well, we're putting short concept modules like this to teach young children algebra. How many faces on a cube? 6. Okay, they fill in a table. How many corners on the cube? 8. How many edges on the cube? 12. And then we introduce an equation. The first aspect of algebra, the second is the education. You put the numbers in and you get the number 2. Children of 6, 7, 8-year-olds have no problem. They take the pyramid and they get the same result. And we take a soccer ball, they'll get the same result. It's too hard for me. I make them do that for homework. And we've got undergraduates helping us. Okay, this is...
Here are the Beatles. George, John, Ringo, and Paul. We all know their music, and most of us even know of their impact on the world today. However, whether we realize it or not, we've had more contact with another type of beetle, and they have had far more influence on our very lives. And I'm talking about these beetles, the insects. And this presentation will be all about the wonderful world of beetles. So why talk about bugs? They seem so insignificant and so unimportant. Well, first of all, the study of insects is an extensive branch in modern biological research. And for those chemically minded with us, there's plenty of interesting chemistry that goes on inside beetles. But the most important part of this presentation is to show you that beetles are actually very interesting creatures. And not too many people know about beetles, so we're going to show you some interesting facts. And first of all, beetles are not bugs, they're insects. So we'll talk about a little bit of the entomology of beetles.
I'm going to stop it there. We've got modules created by undergraduates and graduate students on wolves, on secret science and issues like this. And we've revolutionized the resume. Not only have our students, our undergraduates and graduates, contributed to a global cache of information, they've actually revolutionized their own resume. Instead of being in a pile somewhere like this, we send the URL links and we put them on top of the pile. And in fact, if you're marking this, instead of going through these papers and working really hard, you can actually just sit and watch the URL, the presentations, and you can enjoy these presentations by young people wherever you are in the world. That is the future of this particular educational program, and it's already changing things. In fact, our students are actually getting jobs. In fact, I have a lecture on the tricks of the lecturing trade. For assessment, as an example, as I just said, you can just change the marking situation. You don't have to go through that particular pile. And here is the evidence of how valuable it is. Kerry got a Fulbright to Italy. Steve helped us get a Rich Media Award by summarizing what we're doing with this GeoSet program. Prajna got 4 tenure track offers, and they told her when she got to one of the universities, we could see from your GeoSet recording that you can teach. Brittany got into medical school. Jeff says, I think it helped me get my position. Our trees, when she got to the interview, they'd already seen it. The interviewers had already seen her presentation. They said they enjoyed it. She'd already got the job, okay? Vinny, you've just seen in his presentation. You haven't seen Brian and you haven't seen Jennifer. Mark Riley, my colleague in physics, sent the URL links of his students to NSF, the funding people, and they were impressed as well, okay? It has lots going for it. Noriyuki Watanabe in Japan got his job at NHK after his presentation was seen. And here, Steve Aqua, Sam Ruston, Colin Byfleet, and Penny Gilmer are the people helping me. Well, these are the issues. You need imagination to do science. But there are some other aspects of the science that are important, and I'm going to come to these in the last few minutes of my talk. In fact, there is a responsibility if you're a scientist. And there are many networks and organizations that deal with this responsibility. If you're a physicist, we don't need any more atomic bombs. If you're a chemist, we don't need any more napalm. And if you're an engineer, we don't need any more landmines. Those are some of the issues. Leon Lederman said, so many years have passed, and the human race is still saddled with enough nuclear weapons to destroy the planet. We must redouble our efforts to unify the science community against this huge stupidity. And here is the greatest man I ever knew personally, Joseph Rotblat. He was the only scientist who left the Manhattan Project when it was clear that the atomic bomb was not necessary and before it was completed. In his Nobel address, I want to read from it. We appeal as human beings to human beings. Remember your humanity. and forget the rest. If you can do so, the way lies open to a new paradise. If you cannot, there lies before you the risk of universal death. The quest for a war-free world has a basic purpose: survival. But if in the process we learn how to achieve it, by love rather than by fear, by kindness rather than by compulsion, if in the process we learn to combine the sensual with the enjoyable, the expedient with the benevolent, the practical with the beautiful, this will be an extra incentive to embark on this great task. Above all, remember your humanity and forget the rest. And here is Joe in his office, submerged in papers. Look at the papers there, and look at this. Can you believe it? How's that staying up? I don't know. Last couple of slides. My favorite sort of poster is this one by Stein. I'll read it out to you. I'm an alien creature. I was sent from another planet with a message of goodwill from my people. The message says, "Dear Earth people, when you finally at last destroy your planet and have no place to live, you can come and live with us. And we will teach you how to live in peace and harmony. And we will give you 10% off all deep dish pizzas too. Sincerely, Bob." 3 issues. Destroy the planet. I don't know. I'm a scientist. It's so complicated, I'm not sure. But it doesn't look good. That's the scientific attitude. This is a 100, 200, 300-year experiment. We're at the start. The omens are not good. Sometimes I think 70%, 80%. Yes, we are destroying the planet. The second thing, however, I do know, peace and harmony. It is unbelievable that in the 21st century, with all this technology, almost this fantastic contributions of the sciences, that we can't solve our problems by sitting down together and solving them without sending young people to go and kill each other. To use the technologies. In the old days, with a knife, you could only kill one person at a time. Then a Kalashnikov came along, you could kill 20 or 30. And now with an atomic bomb, we can kill whole cities. It is incredible. We should take the politicians of the world, put them in a room all together. How many are there? 100, 200, 50 important ones. Put them in a room and say, you're not coming out until you solve the problems, without sending young people to go and kill each other. But there's one other thing, the pizza and a sense of humor. Without a sense of humor, really life isn't worth living. And so I'm to the end of my talk and point out that we have geoset nodes all over the world now. If you want to help to educate the world, join our club, the geoset club, build a node, contribute what you know about the sciences, and help us to educate the world. Thank you.
Well, that's a great message for the Library of Alexandria. And it fits very well with the youth movement that caused your wonderful revolution. And you could see all these young Egyptians now have the opportunity to make videos and put them up for the world to see and exert leadership and responsibility in those ways. Our last speaker is actually here in person, Richard Ernst. He came all the way from Switzerland. Ernst was awarded the Nobel Prize in Chemistry in 1991 for his contributions towards the development of Fourier transform nuclear magnetic resonance spectroscopy, NMR spectroscopy, as well as for the subsequent development of multidimensional NMR techniques, which have given us so many structures in recent years, both of simple and complex molecules. I was interested to see in his CV that the 2009 Bel Air Film Festival featured the world premiere of a documentary film on Ernst. It's called Science plus Dharma equals Social Responsibility. So I think you're going to hear a lot more about that right now. Ernst?
Dear friends, it's a great pleasure to be here. I know that you are here in the Middle East countries going through a very difficult time in which many of your beliefs have turned into illusions. And quite a number of your leaders have either turned out to be charlatans or criminals. And you have to start to rely on yourself. And you have to think it through, as Harry Krotter has just told it in his lecture. And it's for you a unique chance to open your eyes and use your own personal judgment. And I mean, in some sense, finally you have become mature. And you don't have to rely anymore on other people telling you the truth. I could tell you many stories about my own life, how I was fascinated by nuclear magnetic resonance, how it turned out to be useful for mankind. I could tell you about my passions for music and for Central Asian art. But I think it's more important that I try to provoke a few critical thoughts in you and to give you a few hints in which direction you should think. And let me start out with my very first slide, which is actually the last slide of my lecture. And it's a quote by Karl Popper, where he says, "Optimism is our duty." I mean, when you go through my lecture, it will be pessimistic in many senses. But after all, we are all jointly responsible for what will come, and we have to stay optimistic. Optimism is our duty, and that's expressed by his saying, and I hope you will, despite of all the bad things going around in the world, remain optimists. And after all, it's education which is the most powerful weapon which you can use to change the world. And that's our profession. And we have to try to change as much as we can. Now, the goal is not unlimited personal freedom. Very often people speak about the word freedom, but there are limits. There are limits, but more important are fairness and human respect for all. I think that's what we should achieve, and not just personal freedom, which is an illusion. And education melts away ignorance, and fundamentalism will disappear, leading to a critical mind paired with knowledge, wisdom, and tolerance. That has been expressed also by the previous two lectures. Now, in education, we have essentially two goals. The first goal is helping the poor and the illiterate ones towards help yourself. They cannot rely on the rich people. They are normally not of much help. But the poor ones have to do it themselves. I will tell you about that, a few examples just in a second. And then the second one is educate the upper classes towards societal responsibility, solidarity, and compassion. So the two groups here have essentially different goals to achieve, leading finally, of course, together. Now, the example which I would like to tell you about how you can teach the poor ones and the illiterate ones is an example from India. We go here to Jaipur, and near Jaipur there is a village called the Barefoot College Tilonia, which has been founded by Bunker Roy. And barefoot means people who never went to school. They never had any schooling and still have to perform. And he never went to school, and he still founded this village with the village people. He built up this village, the houses and everything. And I was there 2 years ago. And here, help yourself is really the motto. You see, in the evening, you find in the streets the children sitting here on the street and learning languages. The lower grades, they learn Hindi. They learn the Hindi alphabet here. And the upper classes, they learn English with a barefoot teacher. And the barefoot teacher you see back here in the background. Everybody never went to school, and still they can perform. And they have here these cards which help them to learn English. Now, the entire village is solar. There is no electricity connection to the outside world. They have their solar heaters on the roofs. They have here photovoltaic cells for the electricity at night with a storage house where they store the electricity. They have parabol mirrors shining here into the kitchen in order to prepare the food. And these parabol mirrors are manufactured by the inhabitants of this village themselves, by these barefoot ladies. They have built everything by themselves. And the most astonishing which I saw there were 30 African grandmothers who came to Tilonia in order to be educated into solar engineers. They are building here their solar lamps, and these are ladies coming from Ethiopia, Somalia, Mozambique, Sudan, and so on. They can't talk to each other, but they enjoy it, and they know that they have the same goal, namely to help their own societies. So they build here these lamps, and then they take them back to Africa, into the desert, into the jungle, and enlighten their villages. That's what they learn here, and that's a great goal. And they were so charming there, enthusiastic to see them working on this project. And they have also, for example, here a lady, she is educated into a dentist, also a barefoot dentist. You can do that, obviously. So everything is possible if you want to do it. And that's just an image showing the whole group together with me in the center. And so we should adopt the spirit of this Barefoot College in Tilonia as our own guideline. And I think it's very important that you saw how important ladies were. And I think ladies are the future of mankind. Womankind, we should say. So women will enlighten not only the villages in Africa, but they will enlighten our souls by their compassionate spirit. And they have the proper spirit. And I think that's very important. And women will be the leaders of the next cultural revolution that is so urgent in our society, not only in the Middle East, everywhere in the world. So they will bring us back our lost altruism, the universal compassion, and most importantly, our human dignity. So we have to put a lot of emphasis on education of women. That's a very important issue, very important. And women are the most important and most valuable members of society. They deserve all conceivable support. I mean, men are very often just playboys. Think about that. And education begins at home. I mean, most importantly are partnership and not obedience in the family, mutual respect and not punishment of children or of the wife, liberty of thoughts and not following senseless traditions, societal responsibility also beyond the family. That starts in the family, and family is very important. Education in Egypt, I mean, it improved a lot since the 70s here, that's Egypt, but compare that with other countries. Iran, for example, Oman, they are much ahead of Egypt. So there is still a lot to be done in Egypt in terms of education, especially of women. And I mean, Egypt literacy is relatively high. 60% of females above 15 are literate, and males a little bit more. But still, if you compare that now with the labor force participation of females, it's only 24% are in the labor force involved. Of course, that's not necessarily a bad sign. If they do a good job in the family and raise the children, they are also very important. So, I mean, education of children is the best investment in the future we can think of. And I mean, it was Hassan al-Basri who once said, seeking knowledge at a young age is like engraving on a stone. That's really the fundamental obligation which we have. So, I mean, what we are doing today, we are not doing for ourselves, but we are doing it in order to provide a prosperous and happy future for our children of tomorrow. So we are working for the next generations, and we have to think about that. So we are the caretakers of their living grounds. We try to preserve their living grounds and not using up all the natural resources as we are doing it today. So, I mean, Jonas Edward Salk has said, our greatest responsibility is to be good ancestors. We have to be good ancestors and leave healthy children behind us. And this is not the thing to do. The FGM, I don't want to translate that, you know that. I mean, the beautification plastic surgery done on females, that is not what we should do. And of course, it's being said that females are doing that by their own will. They have the freedom to do it or not, but that's not true. It's embedded in the society and they are forced to do it. Anyway, I mean, if you look at the Egyptian parliament, there are very, very few females in it, about 2%. And I think it's a disastrous parliament. How can this represent our society? That was said by this Dalia Abdelhamid. And after the revolution, everyone wanted to be represented and had to have their voices heard, but women are just being marginalized by all the parties, and that's not good. And women would change it over the system. And you have a candidate. You have even a candidate for Egypt's presidency. She probably will not make it. But anyway, it's important to support her. It goes in the proper direction. And you have to support women politicians. They are, in general, more altruistic and have a better understanding of societal fairness. And don't support the Muslim Brotherhood. Don't support that. I mean, don't vote for them, because they does not provide a healthy basis for a modern state in an international context. It doesn't make sense internationally seen. You might have that internal in a secluded state, but not in a state interacting with other countries as well. Just read what their motives are, and you see that it's not possible to collaborate safely. Anyway, let's go to the universities and speak about the universities. And the primary mission of our universities is the education of responsible leaders for the future. That's what we have to do. We have to provide education of leaders. And you see, academics are predestined to express unpopular truths that are of vital importance for our survival. Nobody else will say it clearly what has to be done. A businessman will not do it, because otherwise he will lose his sales, his profits. And the politician will not do it either, because he would lose his chair. But we academics, we are forced to express what we are thinking ourselves. So take the microphone, stand up and speak up and express your opinion as freely as ever possible on all relevant subjects, because frank personal opinions are more valuable than to avoid making errors. Whenever you speak up, you make errors necessarily, but you can correct them again afterwards. So don't be afraid to speak up. I think that's very important. And for example, the former German president, Roman Herzog, he once made this quote here: without critical opposition, without the engagement of relentless thinkers, a society will degenerate. We need embarrassment, and we need disagreement, we need impertinence and questions of independent brains. And these independent brains, that's you. You have to ask these questions and to confront those people who are ruling. And then at night, you dream. You dream and you develop visions. And when you wake up, you try to implement these visions which you had. And that might lead you in a proper direction. I don't think that all our schools are good. Even the very best can be looked at in a different way. For example, if you look at the rating of universities worldwide, it's always Harvard which stands on top. But read here the book written by Harry Lewis. He was a former dean of the Harvard College, and he has written a book, Excellence Without a Soul. Harvard is excellent, but it's missing the soul which is so important. Anything resembling moral principles or suggestions of greater values has been isolated within the curriculum, if not removed entirely from it. It's not sufficient just to know and to be excellent, but you need also, the spirit behind is also quite essential. And that is missing at this moment, even at Harvard. And I mean, Frank H.G. Rhodes, he once said the sciences have become powerful but increasingly unintelligible to non-scientists. And the social sciences, entranced by microanalysis and quantification, have become increasingly irrelevant to social issues and public policy. And the humanities, embracing fragmentation, otherness, and unreality, have neglected the great overarching issues of human commonality. We have lost the contact with population, and we have to change that. That's very important for the universities, that they are looked at as sources of inspiration. And so that's also Frank H.G. Rhodes, who says, in an era of broken families, dwindling religious congregations, decaying communities, our nation, and he speaks about the USA, this desperately needs a new model of community, knowledgeable but compassionate, critical but concerned, skeptical but affirming. Only then you can solve the problems in our world that will serve the clamoring needs of our fragmented society and respond to the nobler aspirations of our deeper selves. So, I mean, you know, we are not here just to win prizes, and that's essentially being said by a Sufi teacher from Afghanistan. The candle is not there to illuminate itself. We shouldn't just illuminate ourselves, we should illuminate society, enlighten society. That's our task. And if you educate students, leaders of tomorrow, in essence, the classroom teaching, as I'm doing it today, that's not what we should do. I mean, of course, it's a great feeling of superiority to the teacher, this guy down here, when I can look into your eyes and see, and everybody is looking at me. That gives you a great feeling. But students rarely need lectures by readers because most of them can read themselves. So I would suggest exit from the lecture room, start discussion groups, enter the research laboratory, enter the library, we are in the library here, enter professional activities and do something yourself, not just listening. Listening doesn't lead to much results. So learning by doing, trial and error, that's what leads to education. So, I mean, research is by far the best way of learning. That's also the best support of research, that we train young people in gaining experiences themselves by learning, by doing. And that's how I learned my chemistry. That's me here behind my bottles. And I produced a lot of explosions down in the basement of our house. Our house survived and I survived, and therefore I became a chemist. Those who don't survive, they don't become chemists. And you see, after all, what you need are role models. See this little guy. He's following the big ones here. That's important to have also a role model. Of course, I cannot propose you role models here in Egypt. I mean, I just picked out a few famous people, and I thought maybe they could be your role model. But you have to search for them yourself. For example, Mohammed el-Baradei, I mean, he could be one of these role models. He is Egyptian. and he was working in the proper direction. You could think about Naguib Mahfouz. He also expressed great thoughts. You could think, of course, about Ahmed Zewail. He is a great man. You could think about Euclid of Alexandria. Unfortunately, he's dead already by 2,300 years. But, I mean, these could be, in principle, role models. Or this one here. He's essentially my own role model. And he said, we must be the change we want to see. That means we have to do it ourselves. We cannot just protest and go on the street. That doesn't help. You have to do something positive. You have to change the society with your own hands, with your own will, and then it might work. That's what he says. So if we want to educate future leaders, of course they need skills. They need knowledge, but they also need ethics and far-sightedness. That's at least as important as the skills. So this should also be taught at the university, or at least you can adopt it from the role models. So, I mean, when you are a researcher, of course you have to dig deep into the ground of science. This depth is very important for science, that we discover the fundamental rules of nature. But at the same time, you have also to work on this upper, this societal and global level, where you acquire wits, make connections between the different fields, make connections to society. That's also important. So you need both. You need wits and you need depth. And I summarize that normally in terms of a T model. You see the T has the stem which leads deep into the ground. That's basic science. And then you have the upper branch, which are the connections. That's important. And everybody has to work according to this T model. So, I mean, you are responsible yourself. You have to form your own foundations, your ethics, compassion, and foresight, on which you base your future doing. You cannot just adopt teachings from anybody else. So ethics and responsibility are important. And of course, there have been books written about it. For example, this book here on the desk of the CEO of your company or whatever, Ethics for Beginners. Many are beginners, and we are beginners as well. And on our desk also this book, Ethics for Beginners, should be positioned. Who could have written this book? There are many possible sources of such ethical books. Of course, one is religion. You can take it from religion. If you are a Christian, then you adhere to the 10 Commandments. I don't want to go through, but you shall not, you shall not, you shall not, and you shall not. Tells you what you shall not do. And it essentially leads, if you do it properly, to truthfulness, responsibility, and compassion. That's Christianity. Let's compare it with the Quran. And you can compare here all the 10 Commandments, one after the other, with sayings in the Quran. There are a lot of coincidences. And you can find these parallels, so they fit very well together. And again, both are leading to truthfulness, responsibility, and compassion. If you want, you can go to the Dalai Lama. And the Dalai Lama, he says, I have a very simple religion. My religion is just kindness. Be kind to people. That's enough. You don't need more than that. Very simple religion. And I mean, there is the Buddhist creed, which I don't want to go through, with the Eightfold Path of Buddhism, which also leads to truthfulness, responsibility, and compassion. And finally, if you look at all these religions and compare them, you find that all have the same essence. Only the languages are different. They have all the same essence. And this allows you to live together with people from other religions very simply, very easily, if you recognize that the basic truth is the same everywhere. This really simplifies coexistence. And I mean, You see it in this picture. You don't need more than that. These two boys here coming out of a war zone, I mean, they have nothing left than their own friendship. And they are walking together into an uncertain future. But they have the faith in themselves, and they do it, and they survive. I like most ethics expressed by a philosopher. And one of these philosophers is Hans Jonas. And Hans Jonas, he has written the book, The Imperative of Responsibility in Search of an Ethics for the Technological Age. That's exactly what we need. And he says the application of science results demands ethics. You can't apply science without ethics. And he asks a simple question: what can serve us as a compass? And his very simple answer is the anticipated danger itself. Just let's look ahead and see where it leads, what we are doing today. When we use up all the gasoline, our children will have nothing left. If we have destroyed the living beings in the sea, they have no seafood left anymore. When we destroy the air, they can't breathe anymore. So it's very simple to see what we should not do. And he has formulated here the imperative responsibility: act so that the consequences of your actions are compatible with the permanence of genuine human life on Earth. Let's act in such a way that our children, our grandchildren have still the same possibilities of life as we have it today. If we continue as we are doing it today, they will not have these opportunities, and they will run out of resources, and that's certainly not what we should do. So his theorem has a very clear direction, and the answers are very simple. Also, they are difficult to implement. So it's just sustainability and foresight what he is asking for. Of course, you have now these new schools here in this area, and I think that's great, and I hope that these new schools are acting according to this program, that they provide science and knowledge, of course, but in addition, also ethical concerns. For example, the Seville city, you have seen Seville before, which is being in construction now. You see it here, a model of it, how it will finally look like. That's a great achievement and a great goal to achieve. The King Abdal University of Science and Technology in Saudi Arabia is, so to say, the model for this university. That also goes in the proper direction. Or here, the Dubai Knowledge Village, also one of these educational achievements. Or the Qatar National Research Fund has similar ambitions. So really, these are going into the proper directions and can now implement also these new models where you have a relation to society built in. So, I mean, we should open out the windows of our universities. We should appoint teachers with vision and societal and global responsibility. We should emphasize this global context in our lectures and stimulate interdisciplinary discussion groups on societal questions. So, for example, at ETH, we have a special institute of that. We call it Collegium Helveticum, which is a place to conceive a beneficial global future. It's good to implement an institution like that. I mean, the Bibliotheca here in Alexandria is one of such an example. And you need this kind of centers to reflect about the future. And you see, it always seems impossible before you do it. But afterwards, suddenly, it's possible. I have to discuss contents. I don't know how much time I have left, almost nothing, but I have still to tell you a lot of things. We should speak about today's world. We should speak about politics, economy, and environment. I mean, you see, it's so easy to have a pre-recorded message. You cannot stop it. I can be stopped if you use force. Anyway, today's world. What is today's world? Today's world is, of course, has many problems which you have to look at. And I just want to show you one example. The endangered globe in disarray. I mean, climate catastrophes, vanishing resources, wars, poverty, greed, selfishness, and political challenges of Egypt. I don't want to go into the details here. I just want to speak about one example, and that's the banking crisis. The banking crisis where Switzerland was and still is very heavily involved, and which is still going on, and it's still a great danger for all the countries. Let me tell you a story in 7 pictures. 7-day saga. Starting on a Monday morning, we stand here in front of the Egypt Stock Exchange. At 10:30, it's opening. We are going inside. We find this gentleman who is scratching his head because he sees the problems on the horizon, how the stock prices come down. And he scratches his head so much that blood is flowing here. Anyway, in the afternoon, then the New York Stock Exchange is opening, and you see these horrified faces again because stock prices are coming down. And they had a very bad night. They didn't sleep well from Monday to Tuesday. But on Tuesday, we discovered that we all are involved in that. It's not only the bankers who have problems. We all have problems. And we are sitting on a very shaky boat here. And we are in the midst of a deep moral crisis. It's not only financial, it's really a moral crisis which we are in. So you see here our values. The green, the positive values, and the red, the negative values. Money-mindedness, going down to racism and violence. And unfortunately, we have a darkening of the upper half. The green values are gone. The red ones remain. So values are coming down. They're coming down. Wealth still for some people is increasing. And there is a gap occurring between the rich and the poor ones. Within the countries, between the countries, we have the haves and the have-nots which can't communicate anymore. That's what we discover on Wednesday. This lady here, she lost her pension plan. She has difficulties to survive. I mean, this guy anyway had no chances anymore. So, I mean, we are in a very unpleasant situation. So that's our schizophrenic world here. These are the bankers. The bankers in their black dresses, they are fine, and they're stranded boat here, but we are those who suffer. And on Thursday, we recognize that we can maintain this system only by exploiting our sources. For example, the crude oil resources we are exploiting the sea, fishing out the last fish. It's not good what we are doing. And on Friday, we see that we have really destroyed our environment. This was once the Aral Sea, these stranded boats here in the middle of sand. That's not a good future for you. And here's a father coming out from his home and asking the children, please come inside to get some fresh air. You see how it's darkening here, all the dust coming down, and they have to go inside to play their games. And on Saturday, we recognize that also politics and international relations are mostly based on selfishness. Don't think that your leaders are really leading you in a proper direction. They just want to gain their advantages. So never believe a politician. I mean, he normally speaks about justice, but what he means is justification. He justifies what he's doing and doesn't care about justice. This, what you see in the background, that's reality. And on Sunday, finally, you have to time to reflect on that. You go to church, it's half empty, and you try to figure out what's the problem. And it's clear what the problem is. For this one-way road going in both directions, it doesn't lead to anywhere. And this is our limitless egoism. Everybody is thinking just about himself and doesn't care about the rest. That is a major disaster. And if you read on that particular Sunday, after this week, the Neue Zürcher Zeitung. You can read it here. I translate it into English for you. Here, the bubble was nourished by a number of human properties, by lust, exorbitance, arrogance, vanity, exaggeration, unreasonableness, incompetence, not only at Wall Street. Authorities, governments, media, and the broad public suffer all from the same disease. We also suffer from this disease. We egoists. And you can read the Spiegel, the German newspaper or magazine, the erotics of money. You can see here what you do when you wake up and you shave yourself. You kiss yourself in the mirror because you like yourself so much and you don't think about the rest. So this is our business model. When we wake up, when we think, what shall I do today, we develop our day program, and we don't stand up, get out of bed unless we see a profit for ourselves. This feedback loop is very important. Egoism, the driving force of our system, everywhere, in business, in politics, in science as well. And I mean, then, of course, I mean, the economists, they tell you, yeah, that's Adam Smith who has published that a long, long time ago. And we know that it is true, but it's not true. It is not from the benevolence of the butcher, the brewer, and the baker that we expect our dinner, but from their regard to their own interest. Everybody only asking for his own interest. I mean, it's a very immoral ethics which is proposed here. But it's not so much Adam Smith who has proposed that, but it's our interpretation. It's our interpretation. He speaks about the invisible hand, but I tell you there is no invisible hand anywhere in the world. And he has written a book on moral sentiments where he expresses benevolence, compassion, and sympathy. And after all, it's really our interpretation which is immoral. Anyway, you know this guy here. He is the one defending free market economy, free market, the homo economicus. And he maximizes the profits, maximizes the shareholder value, no ethics, no moral, no global responsibility. These words don't exist in his vocabulary. And you know that's not only in business like that, that's everywhere like that. In sports, for example, you see here the boxing. I mean, this is the winner and the loser down here. And I mean, the winner doesn't think about cooperation. He thinks about competition. And if you are standing up and the other is lying on his back, then you feel great. But if you lie on your back, then you finally start to think about possible cooperation. And everybody has to run fast, faster, faster, faster every day in order to be ahead of anybody else. So speed is very important. Speed, speed, speed. But I mean, not only speed matters, also the direction matters. If you go in the wrong direction with maximum speed, it's not good. And we are sitting here in this acceleration trap every day, faster, 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 faster. It's rotating, rotating, rotating. You know what remains at the end of the day. Just stress. That's how you go home, meet your children, meet your family. You are tired, you turn on the TV set, and you go to sleep. That's not an existence which is beneficial for the environment. And our poor children, they have to grow up in this swamp, and they are caught by the attention deficit hyperactivity disorder. They can't sit still anymore. And if I see you sitting so neatly in your chairs, I'm sure that you all had your portion of Ritalin before. That's why you are so quiet. And Ritalin, of course, produces all these pillheads here in school. But whether this is really a cure or a kill by drugs, you can ask yourself. So, I mean, we have really to work towards, to avoid the sinking of the boat, to keep our boat afloat. Politics, economy, and academic community have all to work together. So we are standing here in the middle of economy, politics, and society, and are a very important ingredient. standing for fairness, for foresight, and for responsibility. And this is a green model which I would propose. When we wake up in the morning and ask ourselves, what shall we do today? We think, what could be a profit of society? We are working for society, of course. We are also members of society, so we also take advantage of it. But the initial goal is to really satisfy the needs of society. Responsibility as a driving force, that's a better approach than just egoism. Okay, I could speak about politics, economy, environment, and so on. I really don't have time to do that. I mean, there is a lot to be said about this model, where the USA has much too strong weight, and we, the rest, we are missing our weight. We should put on more weight on this side here. I know there is a very nice saying characterizing our world today. The US cooks the dinner. These are the cooks. And we in the EU, we just do the dishes. But I can tell you, the Egyptians are also just dishwashers. Everybody is a dishwasher except for the USA. That's an American who expressed that so neatly. And it's almost true. Of course, we have to do something to balance that out. And what we have to do is to strengthen international interactions, international organizations, the UN, the International Criminal Court, the WTO, and so on. We have to work against this dominating force on the other side of the Atlantic. So, I mean, these associations, they help safeguarding a beneficial global future. They help. And for example, Joseph Stiglitz, a Nobel laureate in economics, he has written this book, Globalization and its Discontents. And he says in it that we cannot go back on globalization. It is here to stay. We cannot change that. But the issue is here how we can make it to work. And if it is to work, there have to be global institutions to help set the rules. I mean, these are also two interesting guys. You know them probably. I mean, this, for sure, that's Einstein, and here Sigmund Freud. They had a letter exchange long, long time ago, 1932. And Einstein was writing to Sigmund Freud, the quest for international security requires that each nation unconditionally surrenders some fraction of its liberty of action, of its sovereignty. You have to give up some of your freedom in order to be able to collaborate with the rest. You have to do that in your family, you have to do it in the state, and you have to do it internationally. Otherwise, collaboration doesn't work. I mean, a good example here is the European Union. I mean, the European Union, they have the idea of unification, and that is really a glimpse of hope in a dark world. Except for the black sheep here in Europe. This here, you know what that is? That's Switzerland. And I'm standing as a black sheep in front of you, and I'm so sorry about it, that we didn't join the club yet. Collaboration would also be important for us. Anyway, these are just a few concerns. I mean, of course, you could have the same system here in East Asia, East Asian unit. You could have a South Asian unit, and you could have a Middle Eastern union. And I think that's very important. Very, very, very important. Work together between your states and don't fight all the time. Come to an agreement between the Arab nations or the Middle Eastern nations and work together. That would be so important. You could reach so much more. And I mean, you have so many people here in Egypt, but you don't have any resources. And Saudi Arabia is empty, has a very few people, but very rich resources. So put these countries together. That would really make sense. You could think about Africa in this way. You could think about South America in this way. All these unions would be very beneficial. I could speak about economy. I don't want to do that here. I said already enough about it. Let's skip it. So what we need is a responsible market and not a free market. Responsibility instead of freedom. I could say a lot about ecology, which is also important here in Egypt. I mean, you have to minimize your needs and your dependency on unnecessary commodities, reduce them as much as ever possible. Reduce your ecological footprint. And this is the footprint of Egypt, going up and up and up. And the biocapacity of Egypt is going down and down and down. And this difference here, you cannot balance within the country. You need good friends for that. But you need the friends who support you, otherwise you cannot survive. And if all countries are in this problem, then you have a major disaster on the globe. I mean, there are here the brown ones, which have problems. The green ones are still okay. You know water is one of the major issues in this context, but I don't have to go into that. You know that all too well. I don't want to quote that. We need new energy sources, but in the desert there are so many possibilities to gain energy. And for example, this desert tech problem in the desert here, where you could generate enough energy for everybody. I don't want to go into it. But I mean, you see, that's our vehicle. Our vehicle, where the society are the passengers on the vehicle, being entertained by the politicians, kept in a good mood, that they don't jump off the vehicle. We have industries, enormously strong power with driving the vehicle forward with maximum speed, maximum profit. They don't care whether the vehicle finally goes to hell, because the profits are spent much before reaching hell. And we have academia, which should serve as a steering wheel, which goes in the proper direction. That's the model, how I see our function as steermen in our world. Okay, I mean, the last chapter I probably can skip, because that just tells you what we should do. We should open our doors. We should have outreach programs. We have sent, for example, in this Jubilee year, a few years ago, 150 professors out on the streets of Zurich. They had to be teaching to the public coming down from the hill here, from the ETH into the lower parts of the city. We have built them temples here, and these temples, they have to provide information, start a dialogue, public feedback. I mean, these are the kind of projects which we need for having a direct contact to society. You could do that very well here in Alexandria. You could do it in Cairo. Anywhere you can do this kind of teaching programs, and you learn a lot from it yourself. I don't want to go into that. I mean, that's me standing in front of the public here. We had always full houses. We had in 3 weeks 330 lectures of this type, and it was a great success. We had a show here near the railway station of Zurich, and we had 220,000 visitors in 3 weeks. We had experiments for the smaller ones. We had experiments for the middle-aged ladies. We had experiments for grandma. That's what we call lifelong learning. Lifelong learning is very important. Anyway, we have to start early, get the children into a chemistry lab, do chemistry experiments with them. And we have to build this kind of bridges, these bridges to society based on foresight. That's very important. I'm coming to my very last slides here. That's our function. The formation of responsible and innovative leaders with long-term vision willing to serve society. This is the principal obligation of our universities. We should act as pathfinders of society. And I mean, you know, François Rabelais, he has said that 450 years ago, science sans conscience n'est que ruine de l'âme. Science without conscience ruins the soul. You need conscience together with science. And if you are in business, then business without conscience ruins the society. You can apply that to many classes of people. And I'm coming back to this slide. That's number one. So we close the circle, and you understand now that optimism is our duty. Also, there are so many bad facts going on today because we are jointly responsible for what will come in the future. Thank you for your attention.
Too long. Well, we've gone well into the recess period, but I think we should take a few questions nevertheless. If you could have a question, please go to the microphone. There's microphones in the hall, in the aisles. There are also somebody supposed to be somewhere with a microphone, carrying a microphone around. Where are you? Questions?
Nobody awake.
Nobody awake? I can't see anything. Okay. Yes.
Assalamu alaikum. I am Islam. I study Business Administration, Arab Academy Transport, Department International Marketing. أنا بعتذر، أنا هتكلم بالعربي لأني بعتذر باللغة بتاعتي وعشان ما يبقاش فيه غلطات يعني. فأرجو إن يبقى في حد يترجم للبروفيسور. أنا يعني سعيد جدا إني المحاضرة تناولت جانب كبير جدا من جانب دراستي وهو الاقتصاد والأسواق العالمية والانفتاح والبورصات. طبعا جميع
So what is the question? I'm sorry.
Okay.
Shall I translate?
That was in Arab.
He's very happy that the session went through his field study, business economy.
طبعا البورصة هنا في مصر تختلف كثير عن البورصة في العالمية، لأن معايير الائتمان بتختلف في مصر عن المعايير العالمية، فمن مسمى دوت المخاطر بتكون أقل. أوكي، السؤال إزاي إن احنا نحقق عدالة اجتماعية من خلال السياسات الضريبية اللي بتبقى مثلا على الورق بشكل معين وفي الواقع بتكون بشكل معين وسياسات مختلفة في الدول يعني.
It's how to achieve equality on the field. Concerning taxes.
Yeah, all I can say, it was a great question, and I completely agree with you what you have said. Also, I didn't understand this.
الجانب الثاني يعني احنا بندرس في البيزنس اذا تدنى مستوى الاخلاق.
It's very hard to hear it. They are translating the question.
فالموضوع يعني
Please, for everyone, please, if you have a question, it's just direct it right away in 1 minute, please. And one question per person, because we are running out of time.
النقطة الأخيرة اللي عايز ألمح ليها إن الوهم اللي ممكن تكون الشعوب وصلت له زي ما حضرتك بتقول ممكن يبقى حقيقة في حالة لو كان في إصرار. بس شكرا.
The other question on the other side, please. Here.
Yes.
Ali.
Okay. My name is Ahmed Tariq. I'm very happy that our scientific scholars are not talking just about science. They are talking about conscious and talking about societal fairness and something like these issues that we really need. But I really need to ask the professor. You said don't vote for brother Muslimhood. Muslim Brotherhood, but I'm not from them. But I think it's from fairness and justice and consciousness that anyone must hear from them before talking about their slogans. And you must, I think it's from wisdom that one must hear from them about their slogans and what that mean actually. Thank you, Doctor. Thank you.
You see, I don't think that you should have lectures exclusively on responsibility, on ethics. You should embed that into science. It should be applied ethics. It should be applied responsibility, and then it makes sense. But I mean, don't isolate it out into an individual lecture. What it's also difficult is to, for example, to test the students afterwards, if you have been speaking about such a subject, unless they just learn it by heart, and that wouldn't do much good either. So it's not easy to teach that, but you build it into a lecture course. Just a few remarks at the beginning, at the end, and you should feel then the spirit of your teacher.
There?
Yes, I thank very much all the lecturer, and my question is directed for Professor Richard Ernest, whom I like very much his talk, and I want to ask him what should have to do on the international level for preventing the destruction of environment. We know that the countries like United States and other countries do a lot of experimentations to break the envelope of the earth, and that make accumulation of heat and make also the penetration of the cosmic rays to the earth is very destructive. And I don't know if you have any plans for international forum or something which we can do, all of us, like he said in his talk, that we have to collaborate to prevent these things, because it's for the future of the new generation. Thank you.
Yeah, I mean, the environment is one of the best examples to show how we are dependent on each other. Internationally, that we have to work together, and that there have to be international agreements and international controls as well. A lot is being done already in that respect. There are many councils speaking about that, but we can never do enough. We should always try to do even more than we are doing today. We cannot say nothing is being done, but we should try to emphasize that wherever we can. That's about as much as I can say.
Who will emphasize? We are not a decision maker in such things.
We are teachers. We are teaching
yes, okay.
the next generations. We are responsible for the future. We cannot change the system now. But we teachers, we are working for really for long-term future, for our children, for our grandchildren. That's our task. And that's what we have in mind. We cannot change the politicians of today. We have that not in our might. So
Thank you.
we are thinking far ahead. We have to think far ahead. That's our responsibility.
Here?
Thank you.
Yes?
Okay. I'm Lamia Hayat, a biochemist from Kuwait University. My question is about the organizations, that they have to put the rules so that they interact for the best of the global society. I just want to pinpoint about the organization that you have suggested not to fight, and all the Arab countries, they unite and try to make their organization put their rules for their own benefit. How does this go towards that the rulers, you said don't fight, and how the rulers you can kick out without fighting? I mean, from the present situation that we have seen. This just reminds me of the two ways you put that they all go to first direction. So I'd like to hear your comment.
I mean, all we can do is to try to convince the important people and hope that next generation is doing it better than today. Of course, we can do it on a small scale, to have discussion groups coming together with people from different universities organizing conferences. That's a small contribution to it. but we can.
What time do you want to stop?
We just do as much as we can and hope that it goes in the proper direction. I mean, it's a subject which needs a long time to discuss, and we probably cannot do it in any comprehensive way now.
Okay, we'll have just a few short more questions. Only the people standing, please.
My name is Hatem Abdel Fattah. I am an undergraduate student in 4-year in Science Banha, chemistry department. My questions what is your explanation about definition of the time in the point of view of science and politics and any other fields? Second question,
What was the first question? Creation of?
I want to ask about the time. What is time?
What is?
Time.
What is science?
Time. Time. T-I-M-E.
Time. What is time?
It's first.
Yeah, that's a very good and very difficult question, and I mean, myself, I cannot give you a good answer for that. I mean, either it's very clear or it's completely unclear. And I mean, I'm switching back and forth between these two extremes, but I don't find really a good answer for that myself. And many theoreticians have also difficulties to answer that.
What's the point of view from or the relationship between politics and time? How can I collect it with each other?
I mean, Harry Kroto has said it, that we need science education throughout our society. Also the politicians, they need some science education. And we need also more scientists going into politics. I think that's very important, that scientists are not afraid of entering politics. Of course, it's easier to work at your workbench and do just experiments for yourself alone. And going on stage, political stage, it takes more courage. And sometimes you have a lot of disappointments, but we have to do it. And it's important to stand up and to express it. So I think these are ways how you can bring science and politics together, and we have to do more in that respect. And also, I mean, including politics a little bit, not in the details, but in our lectures. We shouldn't just keep it out. It belongs to our society, and the scientist also is a member of society, and he has to articulate himself about political issues.
Okay, please, just one question at a time, because you have many friends standing there.
So could I just ask Dr. Lane if he would like to make some remarks about the questions you've heard? From Strasbourg, would you like to make some comments, Dr. Lane?
Yeah, there would be a lot of comments one could make, because obviously these are very broad subjects. Maybe one comment I would like to make. It is easy to say we, but you know, people disagree. We cannot say we. We cannot say we do that, we should do that, and so on. Just people disagree. And that's even a characteristic of democracy. We have right now an election in France, and it is quite split, and even some of the extreme right is coming up again. That means that I cannot agree myself with that, but it's nevertheless part of our country. And this is really a big concern. So it's very difficult to say we. It's very difficult to say we should do this, we should do that. It's just that people have to do it, but will they do it? One question also was one raised by Harry Kroto. He said at one stage, make up your opinion yourself. I don't think this works. When I go into an airplane, I want the pilot to be trained. I want a surgeon to be trained. I want a pianist to be trained. We need competence. I cannot judge whether the pilot is good to take the plane in his hands. I cannot judge whether the surgeon is good. I cannot judge, I can somewhat better judge whether the pianist is good or not, but I think it is not so easy. We need expertise, we need competence, and we have to have confidence in the people who have the competence, or at least are supposed to have it. Maybe the third point, referring to what Richard Ernst just said. Richard, of course, is very interesting, very nice talk. However, for instance, one point, Hans Jonas is not somebody I personally admire so much. I think he has done important things to make people aware of the need to be prudent, to have precaution, to be careful. Let's say call it careful. But we cannot judge that the life should continue like today. I cannot claim that the planet should be in the future like it is today. The planet has always changed. Of course, we have to try to minimize our impact, but I think it is very difficult to apply this so-called precautionary principle. And I personally think that introducing the precautionary principle in the French Constitution was a big mistake. It's very difficult to do this, and we should be careful. Let me just tell you, when you want to cross the street, you can either look up and down and be careful, or not cross at all if you apply the precautionary principle. I've got a few other things I could say, but please, I mean, for time, this time is already gone. I think I should stop.
Okay, well, thank you very much. Obviously, this could go on for another 2 hours, and it'd be very fascinating. And unfortunately, I am told that we should end. I'm sure Dr. Ernst
maybe
will
we
be
can
around,
just take Professor.
and you could ask him in person.
Maybe we can take because you have just 2 questions here. One person here, one person there. I mean, 2. Just very quick in half a minute. 2 here, 2. Just in half a minute. Can you allow this, please?
Oh, sure. Okay.
Thank you.
Thank you very much. My name is Yasmin Agib. I'm Egyptian, and I'm studying molecular biotechnology at the Technical University in Munich, and I am a junior consultant to the university's president. First of all, I'm honored to sit here in front of Mr. Alberts, whose book I've been studying with for many years. And then it's an amazing chance, of course, to listen to so many Nobel laureates at one time here in the Bibliotheca Alexandrina. My question is maybe from the position of the young scientists and researchers who seek a successful career in science and research and maybe want to become Nobel laureates. And in many of your presentations, you show how creativity is very important, and reflecting on nature is very important for brilliant findings. On the other hand, if we see how the concept of research and career development nowadays is, it's very important to spend a lot of time in the labs to reproduce your experiments to prove that there is statistically significant. Then you have to spend a lot of time on writing application for grants that take much of time, and at the end you might even end up a scientist who's very, very specialized in one thing, basically in your research and the publications, who have the keywords that are important for your research or your current publication, but you don't have time to develop these capacities you're speaking of and the T model and digging deep, but also having time for interdisciplinarity and being aware of the global challenges. So I wonder, was it like this at your times when you developed to become Nobel laureates? Was it that, did it have this shape of responsibilities or even tight regulations for young scientists? Was it different? Or what would you recommend to young scientists, how they should maybe counteract or just follow the systems to become successful and be able to publish here or there? This is my question. Thank you.
Yeah, you said something like you expect some advice for those people who also would like once to become laureates. Yes. I wouldn't recommend anybody to have this as a goal. It can only make you unhappy when you have this goal set yourself. You just wait till it happens by itself. And you do as an excellent job, and it doesn't really matter which job you take. The question is how you do it. The quality is important, not exactly what you are doing. You don't know in which field the next prize will be. So just work in the field which you are excited about, which you are fascinated by, which you know that you have some knowledge in it. Try to make that even better. And in this way, you might have a chance to achieve something. You might achieve not a prize. You can have different goals in your life than just prizes. I don't think that is the proper way to do it. And I mean, I never wanted to gain such a prize myself. Of course, in the very last stages when it became obvious, then you slightly start to change your mind, but before, never. And I think I wouldn't advise you to set that particular goal as your guideline.
I'm told we could go to a quarter of. We got more time. So another question over there?
بسم الله الرحمن الرحيم. أحمد فهمي مصري متخصص في دراسات علم الاجتماع والمجتمع. بشكر السيد المحاضر على رؤيته الأكاديمية والعلمية والإنسانية. وسؤالي بسيط جدا: هل ممكن مستقبلا من أجل العدالة الاجتماعية والظروف الإنسانية للإنسان في كل مكان في العالم إنه السادة الحاصلين على جائزة نوبل وكبار الأكاديميين والعلميين أن يكون لهم اتحاد بحيث ينتهي هذا الاتحاد إلى أن تكون الكلمة العليا في أي مجتمع للأكاديميين والعلميين قبل رجل السياسة، باعتبار أن السياسيين هم الذين يعني وراء الإفساد في كل شيء في العالم وتدمير القيم.
Can we have time for translation, please?
هل هذا ممكن في لحظة زمنية؟ شكرا جزيلا.
So the question is...
well, actually, let me do this more open, please. I have a question for the Nobel laureates winners, that you could have a union for social justice, just to stop the others from going to war. This is as simple as I can do it. No, and it's you Nobel laureates,
the world Nobels,
to have a union to face the evil in this world. If I'm just restating what you just said, my friend. What do you think?
Yeah, I mean, it's often being said that we Nobel laureates, we should have a union and work together and have certain common goals. It's very difficult. I mean, as a Nobel laureate, you are singled out of the crowd and you are put special responsibility on your own shoulders and you behave afterwards as an individual. And it's very difficult to bring these individual laureates together to have a common goal. They have all very different ideas and thinkings, and I think that also makes out their value. Take them as individuals and not take them as a group, and they can be more productive in this way. And so far, I mean, there are certain initiatives which work, but normally the individuals have more power than the whole group.
Question before last, please go ahead.
Hi, I am Anas Sirag. I am from Faculty of Agriculture, Biotechnology Branch, Cairo University. Will you excuse me? I am really terrified. Adrenaline is killing me and I am trying to stop it, but I can't. I have a simple question. Why should I, as a young scientist, be concerned with politics if I think politicians are just stupid? Okay, I should be concerned with science only. I don't find a reason for that. Thank you.
So this as a comment, right, actually, not a question. Unless you want to answer.
That was a statement.
That was a statement.
Okay. Now, the last question, please. We have to close after this question, please. The last one.
Assalamu alaikum. I'll make it as brief as possible. First, I want to thank Dr. Richard Ernst. Your presentation is amazing. Thank you. My question is toward Dr. Lane. Dr. Lane, are you with me? Okay, thanks. Dr. Lane, thank you for your talk. I have only a single comment. You marked, as I interpret, the toxic side effects of some, and there are many chemicals, products, such as DDT, etc. My question is, should we, and by we, I mean you and other scientists and researchers, reconsider our motives in researching and in finding solution? Do the many specialties and the very narrow scope we use in researching causes this chaos and causes destroying our balance and our harmony in Earth? Thank you.
So you speak to
Yeah,
Dr. Lane.
I understood the question. I think you're asking about whether we should continue making other compounds and so on. Yes, I think we should, we must, because we have far not exploited and we far don't know what are the properties of chemicals, of molecules. DDT, I use that as an example. It's one of those cases which indicates that one has to choose. There is no zero risk. One has to choose what is called the benefit danger or benefit risk balance. And I think if you are among the people who have a good chance, a good risk of suffering of malaria, you want to have DDT. You don't want because some person in a developed country has written a book about a fact called Silent Spring, if you remember, that about the dangers DDT might have. Yes, the dangers, there are some, they are minor compared to what malaria inflicts onto people. And so I think one has to evaluate, like any drug you make, and new compounds you're talking about, you are taking certainly drugs. If you have some problems, Harry Kroto spoke about penicillin. Penicillin is a major revolution, as he pointed out, and there are many drugs like that. So I think we should explore, we must be cautious, we must not apply the precautionary principle because then you don't do anything anymore, but we have to just evaluate things and try to take the right decision. And otherwise, I would say we must continue. I don't think the environment should remain constant. The environment has never been constant on the Earth. The United Kingdom, England, was at one time completely covered with ice. And so all this will change, and as was indicated, Africa was close to South America, or South America was close to Africa. This changed over, of course, millions of years, and it will continue to change. The Earth will change. It will change by itself. Limiting our own impact, or let's say controlling our own impact in some way, that is good. Trying to control how we use our resources, that is good. Trying not to pollute because the environment is not nice for us to live in a polluted environment, that is good. But I think the way to do that is to have more research, have to have the better products, more active ones. Take another example. In agrochemistry, the compounds used in agriculture, over the years, it has made enormous progress from using large amounts of herbicides or insecticides and so on, has come down to very small amounts. The problem is often farmers, because they think a little bit more is better, use more than what should be used. So I think a lot of progress has been made, for instance, in this field. Same thing for drugs. Drugs have become much more effective, and rather than using large quantities, you can use now small quantities. So I think we really must explore the world of molecules for the activities they have, for what they can bring us in all types of activities and in all our activities on the Earth.
Okay, well that is the end now. I just want to, before we have housekeeping details from our host here, I just want us all to join in thanking our speakers for their tremendous idealism and their efforts in behalf of science in the world.
As I promised yesterday, you will see me only for housekeeping instructions. We will have our next plenary will be at 1 o'clock here about the many wonders of science. In parallel with it, we'll have track 1 in the lecture hall, which is just downstairs, about the EU-Egypt Science, Technology, and Innovation Cooperation. So be here or there before 1 o'clock sharp. Thank you.